ഇന്നും വലിയ തിരക്കൊന്നും തോന്നിയില്ല റോട്ടിൽ. Live? So all of you, welcome back. Laws of motion. Okay. Last class we had seen what banging of roads. Banging of roads was the last topic. I hope all of you remember. Okay. I'm just writing it one more time. Maximum velocity on a circular level road. What is the formula? Vmax is equal to root mu h rg. Maximum velocity on a banked road. On a banked road. What is the formula? Vmax is equal to root of rg into mu s plus tan theta divided by 1 minus mu s tan theta. Maximum velocity on a banked road. Okay. For no wear and tear, and optimum speed, mu s is equal to what? 0. So Vmax is equal to what? Root of Rg tan theta. I hope all of you remember this equation. This was our last topic. And what were the other topics? Angle of friction, theta equal to tan inverse mu s. Angle of repose also, theta equal to tan inverse mu s. Angle of repose also, theta equal to tan inverse mu s. Angle of friction and angle of repose have the same formula. We have done that. I hope all of you remember these equations, right? Good evening, all of you, good evening. Done, right? All of you done? Noted? മക്കളെ നോട്ട് ചെയ്താ? Listen, these are the important equations of this chapter, laws of motion. Noted? All of you noted? Then next topic, equilibrium of equilibrium of concurrent forces. Concurrent forces. This is the next topic, equilibrium of concurrent forces. Remember, forces acting at the same point, forces acting at the same point on a body are called concurrent forces. Are called concurrent forces. Forces acting at the same point on a body are called concurrent forces. When a number of forces act on a body at the same point and the net unbalanced force is zero and the net unbalanced force is zero and the net unbalanced force is zero, the body will continue its state of, in its state of rest or state of uniform motion along a straight line and is said to be in equilibrium So what is concurrent forces? Forces acting at the same point on a body is called what? Concurrent forces. Now what is our topic? It is not concurrent forces. Our topic is what? Concurrent forces in equilibrium. What is meant by equilibrium? When a number of forces act on a body at the same point and the net unbalanced force is zero, the body will continue in its state of rest or state of uniform motion along a straight line and is said to be in what? Equilibrium. This topic we have discussed before. Now, I am at rest. What happens? My weight is acting vertically downwards. This floor is giving what? Equal and opposite force. So, I am at rest. I am at equilibrium. When we say a body in equilibrium, if the net unbalanced force acting on a body is zero, then we say the body is in equilibrium. It's a very important point. If the net unbalanced force acting on a body is zero, comma, the body is said to be in equilibrium. The body is said to be in equilibrium. If the net unbalanced force acting on a body is zero, the body is said to be in equilibrium. Okay, please note down equilibrium of concurrent forces. If the net unbalanced force acting on a body is what? Zero, then the body is said to be in equilibrium. I think it's an on time, tug of war time. Now, tug of war time, if two bodies are having exerting equal and opposite forces, what will happen? The tug will remain at its position. If they are exerting equal and opposite forces, then the competition will end in a draw. If the right person is exerting more force, it will go towards the right side. Then it is not in equilibrium. If the left person is exerting more force, it will move to the left side. Then it is not in equilibrium. If it is in equilibrium, all the left side forces will be what? Balanced by the right side forces, and the net unbalanced force on the body will be what? 0, and the body is said to be under equilibrium. Please note it down. Please note it down. Done? Noted? All of you noted, right? Next, consider three concurrent forces. Consider three concurrent forces: F1 vector, F2 vector, and F3 vector acting at the same point O of the body. By parallelogram law, resultant of F1 and F2 is equal to what? Resultant of F1 and F2 is equal to what? F1 vector plus F2 vector. Now let's see. This is the common point. This is F1 vector. This is F2 vector. I hope all of you remember the parallelogram law of vector addition. If two vectors are represented by two adjacent sides of a parallelogram, then the resultant will be what? Diagonal of the parallelogram drawn from the same common point. Any doubt? So this will be what? F1 vector plus F2 vector. See, this can be replaced by a third force. This is F3 vector. Let the point be O. See, consider three concurrent forces: F1, F2, F3. acting at the same point of the body. F1, F2 and F3. Three force vectors are acting at the same point. Since F1, F2, F3 forces are acting at the same point, we can call it as what? Concurrent forces. What will be the resultant of F1 and F2? It will be F1 vector plus F2 vector. Now, remember, if the third force F3 vector acts on the body such that F3 vector is equal to minus of F1 vector plus F2 vector. See, F3 vector is acting in the opposite direction of the resultant of F1 vector and F2 vector. I am repeating, that word is line is confusing. F3 vector is acting in the opposite direction of the resultant of F1 vector and F2 vector. That is the reason why there is a minus sign. That means what? F3 is equal F3 plus F1 plus F2. That minus, the whole term is bringing to the left side. So F3 plus F1 plus F2 is equal to what? 0. So what happens? Thus these three forces in equilibrium can be represented by the sides of a triangle taken in the same order. See, this will be really confusing for some of you. Let me explain this. I am taking two triangles. Let the first one be F1 vector and second be F2 vector. Now, closing side, this will be what? Taken in the opposite order. F3 is equal to what? F1 plus F2. Any doubt? This we have seen. Here F3 is equal to F1 plus F2. But what is our case? F3 is equal to what? Minus of F1 plus F2. So if two vectors are represented by two adjacent sides of a triangle taken in the same order, then their resultant will be the closing side of the triangle taken in the opposite order. That is triangular law of tradition. But here F3 is equal to what? Here F3 is equal to what is the speciality of F3? F3 is equal to minus of F3 is equal to minus of what? F3 is equal to minus of F1 plus F2. So if I taken in the opposite order, it will be what? Plus F1 and F2. But F3 is equal to, we have proved that F3 is equal to what? Minus of F1 plus F2. So it should be taken in the opposite order. See the opposite. See the first, in the first case, F3 was in what? F3 was what? F1 plus F2, that was in the same order when F3 is equal to F1 plus F2. That is the normal way. But here from this equation, we know that F3 is equal to what? Minus of F1 plus F2. So it should be in the same order. So F3 is equal to what? F3 vector is equal to minus of F1 plus F2. Any doubt? F3 is equal to minus of F1 plus F2. അത് മനസ്സിലായോ? ഞാൻ ഒരു വട്ടം കൂടി പറയാം, രണ്ടും കൂടി വരയ്ക്കാം. അതായത് this is f1 vector, this is f2 vector, then if f3 is equal to f1 plus f2, that is the original triangular law of tradition that we have studied. If two vectors are represented by the two adjacent sides of a triangle, then the resultant of these two vectors will be the closing side of the triangle taken in the opposite order. It is that case when f3 is equal to f1 plus f2. What is our case, present case? f3 is equal to minus of f1 plus f2. So how to represent that? This is f1, this is f2, then f3 is equal to what? f3 is equal to what? Minus of f1 plus f2. So it should be taken in what order? Same order. Any doubt? f3 is equal to minus of f1 plus f2. So it should be in the same order. Any doubt? Note it, please note it down. Others, good evening. Note it down. Next is a problem. Let's see. A mass of 6 kilogram is suspended by a rope of length 2 meter from ceiling. A force of 50 Newton in the horizontal direction is applied at the midpoint of the rope as shown. What is the angle the rope makes with the vertical in equilibrium? Vertical in equilibrium. Now let's see, this is the question. This is a question given. A mass of 6 kg is suspended. So first, a mass of what? Mass is equal to 6 kg is suspended by a rope of length 2 meter. Okay, let's see. From the ceiling with a force of what? 50 Newton. So what is the force it carries? 50 Newton. A force of 50 Newton in the horizontal direction is applied. So we are applying a force of what? 50 Newton. So when a horizontal force is applied, the figure changes to this figure. There is a horizontal force of what? How much? 50 Newton. So let's say this is the tension T1. Always remember tension acts away from mass. So this is T2 and this is also T2. And force of how much Newton? 50 Newton. Left horizontal force of what? 50 Newton is applied. So this is tension T1, this is T2, this is also T2. Then this is the angle. This is the angle theta due to this horizontal force. So initially it was in this direction. When a horizontal force is applied, it is standing at an angle theta with the vertical. That is given. What is the angle the rope makes with the vertical? This angle theta we have to find out. Any doubt? See, students will be having confusion here. Why I am giving T3 as equal to 50 Newton? Because in the question it is given that there is a horizontal force of 50 Newton. A wire or a string is standing straight means there is a tension. So its mass is what? 6 kilogram. So force will be what? 6 kilogram weight. You know that, right? If mass is 6 kilogram, force will be what? 6 kilogram weight. That is 6 into 9.8. That all of us we know. Or you can take, it's given that G should be taken as 10. G should be taken as 10 meter per second square. Mass of rope is negligible. Mass of rope is what? Negligible. Mass of rope is negligible. Any doubt here? Any doubt here? Makkale doubt unda? Okay, this is the situation. This is the original figure. So let me draw this figure one more time. See, I am drawing this figure one more time. There is a horizontal force. Due to that force, there is an angle. And the horizontal force is what? T3 equal to 50 Newton. Tension T1 acting towards the equilibrium position. There is a mass. M is equal to 6 kg. So weight is equal to 6 kilogram weight WT. This is T1 and there will be T2 here and also here. So why, some might be wondering why there is 2 arrow mark for T2. See, this tension is acting away from the mass and also one tension in the opposite direction. It is in equilibrium, so it is standing straight. Now let me complete the figure. For completing the figure, if this is theta, I can say this is also theta. What is the reason? Alternate interior angle. If angle with the vertical is theta, then this is also theta. Why? Alternate interior angle. Now, see this right side T3 equal to 50 Newton. So, there will be equal and opposite force this side. And if this angle is theta, this has to be what? T1 cos theta. Then this angle has to be what? T1 sin theta. Any doubt here? Any doubt here? The angle with which one with angle made with one side is what? Cos component and the other side is what? Horizontal component is cos component, other side is what? Vertical component. Any doubt? Now these forces are in equilibrium. So we can equate horizontal and vertical forces. Any doubt? We can equate horizontal and vertical forces. Any doubt? A doubt now? So while equating, we will get T1 cos theta balances what? T1 cos theta balances T1 cos theta in this direction. What is the opposite force? 6 kilogram weight, that is 6 into 10. That is 60. T1 cos theta equal to 60. Then T1 sin theta is equal to what? T1 sin theta is the left side force. It is balanced by the right side force 50. So equation 1, equation 2. Equation 1 by equation 2 gives what? T1 gone, sin theta by cos theta equal to what? Tan theta equal to 50 by 60. That is tan theta equal to 5 by 6. Theta equal to what? Tan inverse 5 by 6. Tan inverse 5 by 6. Any doubt? Theta equal to what? Tan inverse 5 by 6. With the state students can use scientific calculator. With that scientific calculator, they will get the angle value 39.8 degree. Any doubt? മക്കളെ അത് മനസ്സിലായ? ഈ പ്രോബ്ലം മനസ്സിലായ? മനസ്സിലായ? ഇത് ഇച്ചിരി ടഫ് ആയിട്ടുള്ള പ്രോബ്ലംസ് ആണ് കേട്ടോ. നോട്ട് ചെയ്യണ്ട, എല്ലാവരും വരച്ചെടുത്ത് നോട്ട് ചെയ്യാം. Done? All of you done? Finish? അടുത്ത ക്വസ്റ്റ്യൻ നോക്കാം. നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ. Determine the tensions T1 and T2 in the strings. T1 and T2 in the strings. See, this is the original question. They are saying this is T2 and this is 60 degree. This is 4 kilogram weight. Okay. So this is tension T1. This is given as T1. Okay, now let's see. Now I'm solving it by drawing another figure. This is what? T2. This is T2. This is T1. And this one is what? 4 kilogram weight. Now let me solve this. So these are already there in the original figure. If this is T1 and they have given this as what? 60 degree. If this is 60 degree, now see, I am extending. So if this is 60, this is also 60 degree. So this has to be what? This side has to be T1 cos 60. So this has to be what? T1 sin 60. Now I am writing, equating forces in the horizontal and vertical directions. What we will get? T1 sin 60 is equal to 4 into 10, because it is 4 kilogram weight. I am taking G as 10. So T1 sin 60 is equal to what? 4 into 10. Now T1 cos 60 is equal to what? So T1 cos 60 is balanced by what? T2. So equation 1, equation 2. Dividing equation 1 by equation 2 means what? T1 sin 60 by T1 cos 60 is what? Tan 60 is equal to what? 40 by T2. What is tan 60? Tan 60 is equal to root 3. So root 3 is equal to what? 40 by T2. So T2 is equal to 40 by root 3. Any doubt? After solving, T2 will be 22.63 because root 3 is what? 1.73. Now, once you got T2, then you can apply that value to any equation. So, T1 cos 60 is equal to what? T1 cos 60 is equal to T2. So T1 cos 60 is what? 1 by 2 is equal to T2 is what? 22.63. So T1 is equal to 2 into 22.63. Then T1 will be 45.26 Newton. Any doubt? Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? ചെയ്തതിൽ ഡൗട്ട് ഉണ്ടോ? ഇത് കുറച്ച് ഹൈ ലെവലാണ്, പക്ഷേ NCERT-ലുള്ള ടൈപ്പ് ക്വസ്റ്റ്യൻ ആണ്. അതുകൊണ്ട് എനിക്ക് ചെയ്യാണ്ടിരിക്കാൻ പറ്റില്ല. ജെഇക്കും ചോദിക്കാറുണ്ട്, നീറ്റിനും ചോദിക്കാറുണ്ട്. അത്യാവശ്യം ടഫ് ക്വസ്റ്റ്യൻ ആണിത്. പക്ഷെ ഇക്വിലിബ്രിയം ഫോഴ്സസ് പറഞ്ഞ കോൺസെപ്റ്റ് ക്ലിയർ ആവണമെങ്കിൽ ഇത് മനസ്സിലാവണം. എന്നാലും ഇക്വിലിബ്രിയം എന്ന് പറഞ്ഞ കോൺസെപ്റ്റ് എല്ലാവർക്കും ക്ലിയർ ആവുള്ളൂ. ഡൗട്ട് ഉണ്ടോ? ചെയ്ത് കഴിഞ്ഞാൽ മനസ്സിലായ ഒരെണ്ണോടി ചെയ്യാം. നമുക്ക് അടുത്ത ക്വസ്റ്റ്യൻ ചെയ്യാം. A mass of 5 kilogram is suspended. Mass of 5 kilogram is suspended by a rope of length rope of length 2 meter from ceiling. A force of 50 Newton in the horizontal direction. A force of 50 Newton in the horizontal direction is applied at the end of the side of the rope. First question, what is the angle rope makes with the vertical in equilibrium. Take G 10 meter per second square. Mass of the rope is negligible. Second, what is the tension in the rope? What is the tension in the rope? Let's see. Mass of 5 kg is suspended by a rope of length. This is a mass of 5 kg, m equal to 5 kg. It is suspended by a rope of length 2 meter. Now what happens? A force of 50 Newton in the horizontal direction is applied at the side of the rope. Okay, let's see. So now when you apply a force of 50 Newton, it makes an angle theta with the vertical. And what is the weight? What is the weight here? 5 kg. So downward force will be what? 50 Newton. And this side we are marking, let this be T1, this be T2, then this will be your T3, right? Now equating, if this angle is theta, this also has to be what? Theta. So this will be what? T1 cos theta. Sorry, angle maripu. If this is theta, then this also has to be theta, right? So this will be T1 cos theta, this will be what? T1 sin theta. So equating forces in the horizontal and vertical direction, we can say that T1 sin theta balances what? 50 Newton. And T1 cos theta balances what? That is also 50 Newton. So equation 1 by equation 2. So equation 1 by equation 2 is equal to what? T1 gone, sin theta by cos theta, tan theta equal to 1, theta equal to what? 45 degree. Any doubt? Theta equal to 45. Now we have to find out what is the tension of the rope. What is the tension of the rope? See, here actually in the figure, this is given as T1. We have to find out T1. So T1 sin theta, that is tension in the rope. T1 sin theta equal to 50 Newton. So T1 sin 45 is equal to 50. So T1 into sin 45 is 1 by root 2 equal to 50. So T1 is equal to 50 into root 2. Any doubt? Any doubt? Note it. Doubt now. Note now. Note ചെയ്തെല്ലാവരും. Note. Next topic ആണ് motion of connected bodies. Motion of connected bodies. Motion of connected bodies. See, there is a bigger weight M, so downward force will be what? Mg. See, tension T will be same. Tension T will be same. There is a smaller weight, small letter M. This will be what? Mg. And it's so bigger weight will be moving downwards with acceleration A. Smaller weight will be moving upward with the small letter acceleration A. Now remember, in this type of problem, there are 2 points to be noted. Same wire, same tension. Same tension means what? Same acceleration. Same wire means same tension, comma, same acceleration. ഒരേപോലത്തെ വയറിൽ ഒറ്റ വയറിൽ ഒരേ ടെൻഷനും ഒരേ ആക്സിലറേഷനാണ്. പിന്നെ ടെൻഷൻ ഓൾവേസ് ആക്ട്സ് അവേ ഫ്രം മാസ്. ടെൻഷൻ ഓൾവേസ് ആക്ട്സ് അവേ ഫ്രം മാസ്. എപ്പോഴും ഈ ടൈപ്പ് പ്രോബ്ലത്തിൽ ഈ 2 പോയിന്റ് ഓർത്തോളൂ. ടെൻഷൻ ഓൾവേസ് ആക്ട്സ് എന്താ? അവേ ഫ്രം മാസ്. എന്താ 2 പോയിന്റ്? സെയിം വയർ, സെയിം ടെൻഷൻ. ടെൻഷൻ ആക്ട്സ് ഓൾവേസ് എന്താ? അവേ ഫ്രം മാസ്. പ്ലീസ് ഓൾവേസ് റിമെമ്പർ ദീസ് 2 points. Then our next topic is what? Connected motion. connected motion. Connected motion. Let small letter a be the acceleration. Small letter a be the acceleration with which the heavier mass capital letter M moves downwards and the lighter mass M moves upwards. Let T be the tension in the string. Capital letter T be the tension in the string. T be the tension in the string. According to Newton's second law. What is Newton's second law? A resultant force is equal to what? Ma. So what is the resultant force? See, for the bigger mass, mg minus t. Why I have taken mg minus t? Because from the figure, you can easily understand that the bigger mass will move downward. So which is the bigger force? Is it mg or t? Since the bigger mass is moving downwards, it is clearly understood that the bigger force is what? Mg, and the smaller force is what? T. So that is the reason why instead of force I have written mg minus t is equal to what? Ma. Mg minus t is equal to what? Ma, not small letter ma. Since we are discussing about bigger mass, it should be capital letter Ma. So mg minus ma is equal to what? T. So what will happen? Yeah, okay. So this is one equation. Now for smaller mass, resultant force on smaller mass. Again applying the same logic. Smaller mass, that is downward mg and upward tension. Which one is winning? Which one is greater? The mass is moving upward. So tension has to be greater than the gravitational pull. So capital letter T minus mg is equal to what? Ma. So when you add equation 1 and 2, what we will get? Mg minus T plus T minus mg is equal to m capital letter A plus m small letter a. Here acceleration is same because same wire, same acceleration. So minus t plus t gets what? Cancel. Minus t plus t gets cancelled. So what we will get? Capital letter mg minus small letter mg is equal to capital letter m into, is equal to what? Ma plus small letter ma. So if you take g outside, g equal to what? M minus m, and here a outside, it is what? M plus m. Any doubt? So what is the acceleration of the body? That is our final answer. That is the point to be studied. What is the acceleration of the body? A equal to m minus m divided by m plus m into g. So acceleration of the connected body is what? M minus m divided by m plus m into g. So what we are studying? Motion of connected bodies. What is the equation of acceleration? M minus m divided by m plus m into g. Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യടാ. മോഷൻ ഓഫ് കണക്റ്റഡ് ബോഡീസ് കഴിഞ്ഞിട്ടില്ല, ഇനി കുറച്ചുകൂടി എടുക്കാൻ. നോട്ട് ചെയ്തല്ല, അവർ നോട്ട് ചെയ്യട്ടോ, വേഗം നോട്ട് ചെയ്യേ. Yeah. So what is equation for the acceleration? Equation for the acceleration is a equal to m minus m divided by m plus m into g. Clearly, acceleration is less than what? Acceleration due to gravity. Acceleration is less than acceleration due to gravity because it is m minus m divided by m plus m. M minus m divided by m plus m will be always lesser than 1. Lesser than 1. So what happens? Acceleration will be lesser than acceleration due to gravity. Any doubts? What is our equation 1? Equation 1, ma is equal to mg minus p. And equation 2 was what? M small letter is equal to t minus mg. This is equation 1, this is equation 2. Now, that from the previous page, now equation 1 by equation 2, what happens? ma by small letter ma is equal to mg minus t divided by t minus mg. So a gone. So what happens? Capital letter m by small letter m is equal to mg minus p divided by t minus small letter mg. When you cross multiply, m into t minus mg is equal to small letter m into mg minus t. So mt minus mmg is equal to mmg minus mt. So what happens? Minus mmg plus mmg is there. So mt plus mt is equal to mmg plus mmg. So what happens? T into m plus m, T into m plus m is equal to 2 mmg. So what is tension? 2 mm by m plus m into g. This is the equation for tension. 2 mm by m plus m into g. 2 mm by m plus m into g. Any doubt? Doubt na? This is equation for tension. What is the topic which I am taking now? Motion of connected bodies. What is equation for acceleration? M minus m divided by m plus m into g. What is equation for tension? 2mm divided by m plus m into g. Done? All of it done? Done, right? What is the problem? A constant force acting on a body of mass 3 kilogram changes its speed from 2 meter per second to 3.5 meter per second in 25 seconds. what is the magnitude and the direction of force? What is the magnitude and direction of the force? Magnitude and direction of the force. Please do it yourself. And just tell me the answer. What is the magnitude of force? Magnitude and direction of force. And also acceleration. തന്നെ ചെയ്യോ? Please do it yourself. തന്നെ ചെയ്യട്ടോ. And type your answers. .18 Newton is the correct answer. I hope all of you got that. For those who didn't get, I am doing mass is equal to what? 3 kilogram. What are the other data? Speed from 2 meter per second to 3.5 meter per second. So initial speed is what? 2 meter per second and final speed is what? 3.5 meter per second. In time is given 25 seconds. So with that data we can get v equal to what? U plus at. What is final velocity? A equal to what? V minus u by t. So what is acceleration? 3.5 minus 2 divided by 25. Acceleration is 1.5 divided by 25. Acceleration is what? 15 by 250. If you solve that, your acceleration will be 0.06 meter per second square. That is acceleration. And we have to find out force. Force F equal to what? Ma. M is what? 3. Acceleration is 0.06. So force is equal to 0.18 Newton. See, since we got a positive force, force acts in the same direction. The direction of force is in the direction of motion. Direction of force is in the direction of motion. Direction of force is in the direction of motion. Direction of force is in the direction of motion. Motion the other direction of force. Any doubt? Doubt undo? Note ചെയ്യാം കേട്ടോ. കിട്ടാത്തൊരു നോട്ട് ചെയ്യാം. ഏതൊരു അടുത്ത ക്വസ്റ്റ്യൻ. A shell of 0.020 kilogram is fired by a gun of mass 100 kilogram if the muscle speed of the shell is 80 meter per second, what is the recoil speed of the gun? What is the recoil speed of the gun? What is the recoil speed of the gun? Note it. Point 016 is the correct answer. Others, please try to do it yourself. Yeah. So, what is the formula for recoil velocity? V equal to minus small letter mv divided by capital letter M. Here, mass of the bullet is what? 0.020. Mass of the gun, capital letter M, is what? 100 kilogram. What is the recoil velocity? Sorry, muzzle velocity is what? 80. So what is the formula? V is equal to minus 0.020 into 80 divided by 100. You solve that, you will get the answer minus 0.016 meter per second. You will get this answer. Then minus sign indicates that at last you have to write that the negative sign indicates that recoil velocity is in the opposite direction of muscle velocity. Opposite direction of muscle velocity. Muscle velocity. Note it down. Next, I am giving you a homework. All of you noted, right? Doubt in the noted. Okay, next question. I am giving you a homework. A lift is going up. A lift is going up. The total mass of the lift, the total mass of the lift and passengers is 1500 kilogram. This is the speed versus time graph of this motion. 2, 4, 6, 8, 10. This is 3.6. 3.6 unit meter per second. Time in second. I hope it is good. 2, 4, 6, 8, 10, 12. First question. Identify the region in which lift is under uniform motion. Lift is under uniform motion. Second one, what is the height to which lift takes the passengers? And then third question, what will be the tension in the rope of the lift between t equal to 1 second and t equal to 2 seconds? Please note down the question and do it as a homework. It's a homework. So thank you all of you. It's a celebration time in Kerala. So I wish you Onam Ashamsal Ellavarkum Nalla happy days aikate. Enjoy your vacation. So thank you. We will be coming back on 18th. 18th ആയിരിക്കും നെക്സ്റ്റ് ക്ലാസ് കേട്ടോ. 18th ആണ് നെക്സ്റ്റ് ക്ലാസ്. അതായത് നെക്സ്റ്റ് വെനസ്ഡേ ആണ് നമ്മുടെ അടുത്ത ക്ലാസ്. വെക്കേഷൻ കഴിഞ്ഞിട്ട് നമ്മുടെ നെക്സ്റ്റ് ക്ലാസ് വെനസ്ഡേ ആണ് കേട്ടോ. സോ താങ്ക് യു എല്ലാവർക്കും സ്നേഹം നിറഞ്ഞ ഓണാശംസകൾ. താങ്ക് യു. ഈ ക്വസ്റ്റ്യൻ എഴുതിയെടുക്കുക കേട്ടോ. എഴുതിയെടുത്തിട്ട് പോവുക, എന്നിട്ട് തന്നെ ചെയ്യുക. ക്വസ്റ്റ്യൻ തന്നെ ചെയ്യുക കേട്ടോ. താങ്ക് യു.